Okay, guys, I think we can start now. So this is, I mean, still we are in, I make it only chapter 4, rather than make it chapter 4 and 5. Because we will discuss on the wireless technologies. Okay, it's not related to the concept actually, because here we are talking about the in terms of what we call it telecommunication perspective. So I'm not gonna go for the concept of wireless networks and how we can plan for frequencies, how we can design a cellular network, and that include all the frequency assignment, channel assignment, and some other techniques like handoff and handover, because this one actually the concept will be related to other course, mobile and satellite communication. So for some of you like Martine, she did that course, so she can, I mean, figure out the differences. In that course, we, I mean, really go deep for the concept and basic of wireless communication. We explained a little bit about the GIS technology, starting from first generation until somehow 5G. But we go also for the concept, basic concept of wireless communication that include design a cellular system and also the propagation model, large scale propagation, small scale propagation, and some other techniques that RF engineers adopted in order to design a propagation model. So here we are generally speaking. All right, we are generally speaking about the technologies like 3G, 4G, 5G, and somehow 6G. Okay, so again, there's no concept. So this one actually is much easier in concept and principles of wireless. We have some mathematical formula, and we have some really design questions and problems that include a good understanding to communication systems, including analog and digital. But here actually is just we would like to show the technologies and how they are different with each other. All right, so in terms of generations, as you know, guys, started from first generation. It was analog, all right, analog telephony. And the second generation, we explained last class a little bit about this one, and this one. Second generation, it was digital, all right, digital cellular telephony, and 3G high-speed digital cellular telephony, including video. Starting from here, if you remember, we said we were able to watch some TV channels, all right, some videos by using our mobile phone or mobile station. In terms of 4G, which are currently now here, in terms of cellular, all right, 4G, I mean, recently implemented by ACSL, if I'm not mistaken, which is IP-based, anytime, anywhere, voice, data, and multimedia, and for sure they provide faster data rates. So this one, for example, the timeline starting from 2009, if I'm not mistaken, officially implemented in 2010, and I think 2009 in the US, and after that some other countries follow. So, but still actually currently in use, it's not fully, I mean, 5G is not fully deployed 100%, still working on it, and also working to develop, because in 5G actually we have different phases. So the first phase already launched in 2018. This one Yeah, you can see the 5G, it's lower latency, higher capacity, and increased bandwidth compared to 4G. For sure, there is a big difference, but it's not that much for the first phase. All right, so if we are talking about 5G, as I mentioned, we have different phases. So the first phase, it's better than 4G for sure, but it's not like the, I mean, the dream of 5G still. Okay, I mean, like we can do some remote surgery. All right, for example, if we have a surgeon in Germany and we need to do some, we have a patient here, so we can have what we call it the remote surgery. It's not, I mean, in phase one still we have, I mean, many to do. I mean, the RF engineers many to do, and in order to reach to that level of 5G technologies and applications. So yeah, so for 5G, this one 2015, which is 5G technical form, if I'm not mistaken, created first in 2015, and in December 1st, 2018, South Korea's telecom, the first nation to launch 5G service for business to business. All right, so initially they launched it for B2B, business to business, because in mobile communication and in certain countries they have what we call it commercial wireless communication. All right, they do some business on a specific band. All right, and April 2019, also by South Korea, and it's 1 hour before the US. You can see South Korea and US, they are really moving fast. And always, if you remember, Donald Trump got some conference on 5G. He would like to lead 5G, but South Korea actually before the US, one hour before 5G launch in the US. All right, so and also we can say like 6G, all right, like 5G, but more so, even higher speed, lower latency, and masses of bandwidth, green communications. All right, but this one actually it's too early to say 6G. If you do search, you will find 6Gs. All right, and some papers, some technical papers, some not really technical white paper that discuss about 6G. But as I mentioned, this one actually we have phases. All right, so for example, 600 megahertz, which is the first phase. All right, if you remember 4G, it was like 100 megahertz. So this one actually, the first phase up to 600 megahertz, but still we can work in gigahertz, 40 gigahertz and 60 gigahertz. So this one actually is, I mean, still not reaching to that level where we can really enjoy the advantages of 5G, like I mentioned, remote surgery and real-time applications. So still, I mean, not reaching to that level. In terms of 5G, you can see this one. You can refer to this site. It's very interesting site. All right, they provide some chart and some figures, some info. They have on their Instagram also. You can follow. You can receive some, I mean, on time analysis, which is, I mean, somehow interested if you like. All right. So you can see this one, the 5G networks launched already, for example, in this area, somewhere here, all right, in the Gulf countries, here, all right, in Australia and New Zealand, in Japan and China as well, and 5G technology deployed in this area, here and there. So you can see even in Singapore and Malaysia, it's deployed, but still, all right, investment in 5G. So in end of this year, according to the latest news, will be launched in Malaysia and in Singapore. So maybe you can ask, for example, Singapore and Malaysia is more developed country rather than the Gulf countries. So how Gulf countries launched 5G before Singapore and Malaysia? As I mentioned, if you remember, if we would like to implement 5G, the most, obstacles that we will face is the economy. Because we need to spend really a lot in order to move to 5G. We need to change the base stations, we need to change the antenna, and we need to really work very hard, and we need to spend a lot of money in order to launch this this technology. So that's why you can see, for example, in Qatar and Dubai, they already launched. And for example, Singapore and Malaysia, it's more advanced compared to, in terms of technologies and in terms of research, compared to Qatar and Bahrain, for example. But in terms of economy, this one actually is much better. So that's why they can purchase the equipment, they can recruit some leading company like Ericsson's and all the top companies in order to launch their 5G. So anyway, this is the what you call it, the map of 5G. You can see in here in this area we are not yet. All right, there is no investment and there is no deployment. So yeah, this one actually it's August 2020, so almost a year from now. And this one you can see the South Korea stay in the lead in terms of implementation of 5G. So this one actually is number one. All right, this one comes number two. So Japan and Chinese, you can see even Japan and Chinese, this one also working very hard. China working very hard, but due to some political issues with the US, it's a little bit slower in terms of the story of Huawei technologies and all that stories. And this one, the Gulf countries. All right, Gulf countries, the investment, including all the Gulf countries, 6 or 5 countries. This one, Saudi Arabia, Oman, UAE, Qatar, Kuwait, and Bahrain. 1, 2, 3, 4, 5, yeah, 6 countries. All right, they are also working hard, and also in Turkey, Mexico, and Switzerland as well. Also, in 2019, they start in a small area in the country, Switzerland. All right, so this is, you can refer to this one, and you can generate many figures that related to 5G for sure with some explanation. Then you can understand many facts. So I really recommend this one. All right, for not only related to 5G, related to many other technologies and many other facts. All right. Okay. Sorry guys, so this is the evolution of cellular network. First generation, as we mentioned, it was analog frequency division multiple access, and this one is digital. We call it GSM, TDMA, time division multiple access. And sorry, and this one you can remember we have two standards, all right, two standard, US and Europe. So if we are talking about sorry, if we are talking about GSM, this one it's a Europe, all right. And if we are talking about this one, interim standard 136 and CDMA interim standard 95, CDMA 2000, all this one actually it's US, all right. So US and Europe standard. And also we mentioned that we have some development in between, all right. So we have 2.5G, but this is actually, as I mentioned, is not that much known, only for those who are really working and in this area. For example, we are doing this, studying this, then we have to highlight, all right, we have to highlight that there's some 2.5G, and even in 3G we have 3.5 and we have 3.9. But you can see, I mean, it's not nice to say that now we are in 3.9G, all right. So that's why they merge it and make it 4G. And this one also, it's not commonly known. 2.5G, we have 2G and we have 3G, all right. But in reality, in terms of research development and academia, definitely we have some development in between with some names, for example 2.5 or 3.5, 3.9. This one TDMA, all right, this one TDMA, time division multiple access, and UMTS, which is the universal mobile 3G, it's a CDMA. And moving to LTE, long-term evolution, which is the 4G. All right, this one is 4G, and also we have LTE A, advanced. All right, LTE advanced with extra features, and all right, similar to for example, here we have 2G, 2.5G. We have some enhancement that related to data to provide some connections. I mean, better data exchange. So here same, I mean, LTE. We have LTE advanced, and as I mentioned, in 5G, in 5G we have different phases. So till now we have only 5G, but according to the release, I will show you some afterward the release. Maybe they can call it 5.5G or something like that, or even keep it as a 5G, and after that move to 6G. For example, this is the first phase. Second phase, they will rename it as a 6G. All right. But initially, if you go and you read about the history about 5G, you will see the spectrum, you will see the bandwidth. All right, then you will see that, for example, this one, the first phase within the 600 megahertz, and after that we'll move to smaller antenna. All right, and in order to increase the capacities and also to have more advanced applications. So depend on the working group, and depend on their meeting minutes approval, so they name it accordingly. All right, so it's my fixed at 5G. It's my, for example, they have some release and name it 5.5G, or immediately once this, the first phase completed, then they will move to 6G. Second phase of 5G, they will make it 6G, and that's it. Or sometimes they will they make it as, if you remember, when we explained the cognitive radio and the RAN, regional area access network, you remember we put XG. All right, so that's one actually, that means next generation. All right, next generation network. So whatever technology appear, it's okay, we can name it as XG, next generation network. So this one actually depend on the working group meetings and the outcomes of their meetings. All right, so yeah, in terms of multiple access, you can see this one. All right, frequency division multiple access. Here is time division multiple access. Here is still time division multiple access. Here is CDMA. Code division multiple access, and here actually is orthogonal frequency division multiplexing. All right, orthogonal frequency division multiplexing. All right, so you remember we talked about this one frequency. That means all the users will have different frequencies and same time here use same frequency but in different time slots. All right, here is same frequency but different time slots. Here actually it was, I mean, interesting, which is the what you call it, by all the users they can share the same frequency at the same time. All right, you can see here same frequency, different time. Here, different frequency, same time. But here, same frequency at the same time. But each user has its own code. All right, each user has a unique code. So that's why they can differentiate, and also the interference generated from the users will be less compared to the previous release of multiple access. So in this one, orthogonal frequency division multiplexing. All right, so we have OFDM, this one OFDM, and we have OFDMA. OFDMA. All right, so in this technique OFDM, as I mentioned, this one we call it orthogonal frequency division multiplexing. All right, frequency division multiplexing. So the original bandwidth actually is subdivided into subcarriers. So this one actually we have channels. For example, we have 10 channels, 1, 2, 3, 4, 5 until 10. But in this case, the overall bandwidth is divided into smaller subcarriers. All right, subcarrier. So this one actually we call it multi-carrier system. This one single carrier system. So I mean we have differences. We'll explain a little bit afterward. What's the the advantages, because in the fourth generation we have in uplink we use, for example, single carrier. Okay, but in downlink we use OFDMA. So we have two different multiple access in 4G, all right, 4G cellular communication. One it's related to uplink and one it's related to downlink. In uplink we use single carrier, which is a new single carrier FDMA, all right, single carrier frequency division multiple access. This one in for example in uplink, because the generated interference will be less in single carrier compared to multi-carrier. But in downlink we not that much care about the power, because the downlink will be from the base station. So use OFDMA. All right, OFDMA, this technology, which is orthogonal frequency division multiple access. But here in this case for uplink, for downlink, we don't care, only in when we're reaching to the 4G.
Sir, I have a question.
Yes.
What is the difference between the channel and carrier? So which
actually,
one is better?
Yeah, actually, there's no. I mean, in terms of technology. For example, this one we call it channel. All right, but when we have to this one, which is multi-carrier, all right, we call it subcarrier. So subcarrier also, I mean, same features of channel. In terms of channel, we can use channel. I mean, each user, for example, if you would like to, this is mobile, all right, and would like to communicate to this mobile. Okay, so if we are talking about frequency division multiple access, each user need a channel, am I right? In order to communicate. So we allocate channel for this one, and we allocate channel for this one, and this is the base station. All right, this is the base station. So if we are talking about OFDM, all right, OFDM or OFDMA, we cannot say this one channel because the structure of this one is different. All the channels divided into small subcarriers. All right, so we said that this user will have a subcarrier, all right, and this user, we need to allocate subcarrier to this user in order to communicate. So you can see in FDMA, we allocate channel to this user, channel to this user. But in OFDMA, we said we allocate subcarrier to this user and subcarrier to this user. All right, so in terms of functionality will be same, but in terms of technology will be different. All right, is that clear, Ala? So when we said resource allocation, for example, when we said resource allocation, because in wireless, all right, in wireless, we need to allocate resources. We need to allocate resources to each users. So what type of resource that we need to allocate? We need to allocate channel, all right? We need to allocate channel, and also we need to allocate power. And sometimes if we are using, for example, digital modulation, bit rate, okay, bit rate. So if we are talking about FDMA, I will allocate channel and power. But if I am using OFDMA, I cannot say channel, I will say subcarrier instead. All right, I will say subcarrier instead because as I mentioned, in OFDM, the original bandwidth actually is subdivided into multiple carriers, and each of this subcarrier can be individually modulated. For example, this one subcarrier, I can modulate this one individually. It's not the whole channel. All right. For example, if I'm using FDMA, I use one modulation technique. All right. One modulation technique will be for uplink, for downlink, for the service, the whole service, the entire service. But if I'm talking about OFDMA or OFDM, so that means this one divided into small subcarriers, and each subcarriers can be modulated individually. So in terms of technology is different, but in terms of the way that we are looking to the cellular communication will be same function, because subcarrier I need to allocate to each user in order to make this user able to communicate with its partner. And channel, when I say channel, same. It's a range of a frequency that give a user opportunity to communicate with its partner. So in terms of definition, same, but in terms of techniques, will be different.
Okay, right. It's just like the LTE uses E node B, and the rest they don't. The 3G
Yeah,
they have
exactly.
other technologies.
Yeah, exactly. But this one actually, in terms of, as I mentioned, in terms of functions, that means this one use subcarrier to be able to communicate, and this one use channel in order to be able to communicate. But how this one, what's the nature of this channel, what's the modulation technique of this one, details, it's different. The details actually is different. Yeah.
Okay.
All right. So this one actually, the OFDM also can, for example, have hundreds of subcarriers. All right, hundreds of subcarriers, and the spacing between subcarriers. All right, the spacing between subcarriers is only 15 kilohertz. Okay, if I'm not mistaken, 15 kilohertz. This one for LTE. All right, this one for LTE. Subcarrier spacing normally referred by delta F. So this one actually, it's principles and concept. All right, so in this course we are not gonna go for detail in how the subcarriers, how to allocate subcarriers to users, and how to define the spacing here. And all right, so only the general features of these technologies. Yeah. Yeah, all right. Yeah, so this one, yeah, so when we talk about the multiplexing and multiple access, so multiple access actually it's referred to the improving of capacity. All right, improving of capacity, that means we need to allocate what we call it more users to certain subcarriers. All right, we have limited subcarriers and we have many users. Always number of subscribers is much more compared to the available subcarriers or available channels. So that's why it's really a challenge for the RF radio frequency engineers in order to I mean give the subscribers opportunity to access the available subcarriers. As I mentioned, for example, here in Duhok we have 1.3 millions, for example, or 1.2 or 1 million. So for example, let's say 1 million subscribers. All right, 1 million subscribers, and then the subcarriers and the channel, it's really limited. All right, it's really limited. So that's why here we have some management, spectrum management technique. We can use the for example, depend on the technology in 4G of DMA, all right, of DMA or signal frequency division multiple access, in order to manage the access of subscriber to the available spectrum, all right, or to the available subcarriers if we are talking about OFDM. All right. So as I mentioned, we will not, I mean, I mean, last class we have highlighted about first G and second G. So here we will, I mean, focus on 3G, 3.5G, and 4G, and after that we will check the 5G. All right, we will check the fifth generation. So this one actually it's 4G LTE and LTE-A. All right, so we have I mean different release. All right, so this is, I mean, the mobile broadband reality. Everything is connected. So I mean, everything is connected is good, and also sometimes is not good. All right, so I mean, one of the really challenge for 5G is the security and the privacy, because we will be connected to every single point. All right, so like IoT, Internet of Things. So now if you can search, you can see it's V2V communication. All right, V2V communication. So vehicle to vehicle communication, car to car communication. All right, in order to reduce the road accidents and all that. So it's good, but at the same time it's the privacy. The price that we need to pay is privacy. All right, so that means we can communicate with all cars next to each other. All right, all cars next to each other, and information from nearby cars can be delivered to my own mobile or to my own screen inside my car. So all this one will be really I mean, amazing technology by using the artificial intelligence as well, but at the same time will be critical in terms of the privacy and part of daily life. All right, for sure now we are stick to our mobile devices. Okay, if we can, I mean, count how many hours we are using our mobile in each day, then maybe, I don't know, but maybe 4 hours or 5 hours, so depend. And mobility, internet connections. All right, so these are, I mean, the features and why I mean this technology is so important. And this one, as you know, if we would like to see the timeline, this one actually we call it very fast developing technology, VFDT. all right, the mobile communication, cellular communication, we call it VFDT, which is very fast developing technology. So that means every 5 years, all right, every 5 years there's some new release, all right, some new features. So now we are still using, I mean, 4G, but 5G already released and launched, I mean, the first phase, and the research on the, to make the second phase is ready. I mean, working group working really very hard, especially in South Korea and the US, because there is, I mean, some race between the South Korea and the US, and also China. China working very hard, but what you call it, they have, due to some political issues, they have some restrictions in terms of technologies. But apart from that, also working very hard in to catch the full 5G features. All right, so the benefit of LTE, which is for sure will be speed. All right, higher speed compared to the previous, and low latency, faster download, and simpler network. All right, speed, we can I mean see the speed of the technologies if we'd like to compare it with the 3G and 3.5, and as well even, I mean, we cannot say 2G because at that time it was, if you'd like to compare the speed in terms of the movies and how the movie is clear. And in terms of latency, it's the delay processing time. All right. So if we are talking about latency in network, it is the processing time. Am I right? But if we are talking about the latency in terms of wireless, it's the when the signal actually, it's in terms, this one actually measured in milliseconds. All right, which is the signal will move from source to destination and compacts. All right. So also we have more capacity and new service. Till, I mean, 4G, the service is not that much, I mean, big gap between 4G and 3G, and only in terms of banking. For example, in some countries, you can, I mean, access your bank account from your own mobile, and you can do all the transactions, and you can settle the I mean, bill payment by your mobile. You can pay for the utilities, electricity and water and all that utilities. And also you can make a booking. You can create some virtual account for you. So in terms of transaction and banking and booking will be, I mean, this is the main features for the 4G. But for the 5G, I mean, upcoming phases, not the first phases, we will really see, I mean, a big, really a big difference. Maybe I can share with you some videos about the 5G. What are the services that they are planning to include in 5G? It's really amazing. But this one still actually maybe 2020 or 2030, something like that, or before that. I really don't have any clear idea about the next phase of 5G and what are the real challenge. Okay. All right, so in terms of this one, the 3GPP, as I mentioned, third generation partnership project, or third generation group, partnership project group. In terms of data rate, for sure will be high data rate, downlink and uplink, low delay. All right, latency, user, for example, this one RTT, it's round trip, what's the last T? Round trip delay, but what's the last T? Round trip, maybe time. All right, round trip time delay. All right, round trip, that means source and and destination, source and destination, and when you transmit, all right, and you receive. So this is the round trip. All right, so round trip, I think time, round trip time, round trip delay. All right, RTT, RTT delay. All right, is less than 10 milliseconds. You can see the round trip from this one to this one and back to this one. And for 5G, even, I mean, less than this. I mean, I'm talking about the first phase of 5G, and coming phase, you can see the differences. All right, so yeah, so this one, the delay, the time will be when the source sends signal and receive. All right, this one normally in millisecond, this one in millisecond, and this one for the channel setup, less than 100 millisecond. Channel setup, if you remember, I'm not sure whether I discussed this one or in mobile communication, because in channels we have two different type of channel. We have the VC channel and we have DC channel. All right, so this one, it's a voice channel. All right, voice channel. So normally in mobile communication course, we explain this one in details, and those who have taken mobile, they can remember this one, less than data channel. All right, for example, in one cell, all right, in one cell, maybe we have two voice channel, all right, two voice channel or three voice channel, but maybe we have 10 data channel. All right, 10 data channel. Data channel, actually, the main the main idea actually is to prepare voice channel. So for example, when you press a call, the data channel will start working to make sure that you have efficient credit to make a call. If you don't have, then you'll receive a message. You don't have credit to make this call, please reload and try again later. So if this one is done, they make sure that voice channel are available and check this one whether it's open or closed. If it is closed, then you'll receive the mobile is not available at this moment, please try again later. So all this actually is by data channel. All right, so data channel working very hard. So once your friend press on the phone to answer your call, then this one will be active and this one will be at the background, not active. All right, not active. And once you close, then this one will take again the part. And we said that, if you remember, even if you are not using your mobile, so now I'm not using my mobile, there is no call, it's not active, but I'm receiving data. I'm receiving data. The reason why, because in cellular communication, the technique is broadcast. All right, broadcast. This is base station. Here we have many mobile station. For example, I'm here, so I'm receiving broadcast every second. I'm receiving. All right, so only if the received signal match with my details, then my phone will start ringing. So this is what we call it, the channel setup. All right, channel setup time. That means that the data channel will take care about all the preparation to make the voice call is ready and active. So this one, the time will take less than 100 milliseconds. So this is what we call it by the latency. Maybe in 5G you always hear about the latency, low latency. All right, so these the related issues to the latency in LTE and also in the upcoming technologies. All right. All right, so the 3G is created by ITU, which is International Telecommunication Union, all right, and also called IMT 2000, all right, because I mean, first they launched in 2000, so they said IMT 2000, International Mobile Telecommunication, 2000. All right, so here in in 2000, sorry, in the 3G. In the 3G, we have what you call it WCDMA. So CDMA, we know that CDMA is code division multiple access. That is allow, I mean, all subscribers to access the frequency at the same time, available frequency at the same time, but with different code. But here we have what we call it W. So wide, this one will be wideband, all right, wideband, because the band actually will, I mean, increased by using 3G, all right, so that's why we call it wideband code division multiple access. And in terms of multiplexing, they use FDD, frequency division duplex, and this one CDMA 2000, which is for the US, all right, this one in the Europe, all right, universal UMTS, if you remember, radio access, and this one in the US, and also we have what we call it time division CDMA, all right, time division CDMA, this one in Chinese, if you remember, all right, because China trying, I mean, working hard to have their own standard, all right, to, I mean, it's not to be like depend on the US, because most of the technologies, most of the standards coming either from US or from Europe. So Chinese working very hard to have their own standards, all right, their own standard wireless communication, and are they working on their own standard. And this one, it's related to the enhanced data for the what we call it universal wireless communication. All right, universal wireless communication 136, which is related to 3G, and this one for data enhanced cordless technology, if I'm not mistaken. All right, data enhanced cordless technology. This one, it's a cordless technology. You know the cordless. This is the telephone landline. All right, and this is the set. All right, so there's no wire connection between this one and the base, so you can take this one and you can walk and talk inside your house. All right, so this one we call it cordless. All right, we call it cordless. So also it's they provide a 3G. All right, they provide a 3G with a better multiple access and better range. All right, so this one related to cordless telephony, All right, so here we have what we call it the paired spectrum and unpaired spectrum. All right, paired spectrum and unpaired spectrum. So what do you mean by paired spectrum? What do you mean by unpaired spectrum? So this one actually is related to the marketing of the spectrum. So because normally, as I mentioned, spectrum, each country has some what we call it professional body or some ministry that related to the distribution of the spectrum or releasing of the spectrum. So for example, here maybe we have the Ministry of Technology or Ministry of Information. I don't have any idea, but I'm sure that we have some Ministry of Technology. So that ministry will be responsible in order to sell the spectrum to companies. All right, for example, if you'd like to create your own cellular or wireless company to provide some mobile service, All right, then you will go, for example, submit your proposal to the ministry, and the ministry, once approved, they will give you a band. All right, they will give you a band. So if you are talking about paired spectrum, so that means I mean, the spectrum is normally, organized and sold as a pair, all right, as a paired spectrum. So that means block of spectrum will be allocated for UL, and a block of spectrum will be allocated for DL. All right, UL and DL. All right, for example, in lower frequency band and upper frequency band, or this one for UL and DL. All right, so uplink and downlink. So you will use this one for uplink, and you will use this one for downlink. And you, when you come to create your own base station, the frequency set for uplink will be goes to this one. All right, and the frequency set for downlink goes to this one. All right. So this is what we call it by paired and unpaired spectrum. So if it is unpaired, that means it's a open. All right, open spectrum. All right, so for example, here we have a mixed. All right, we have a mixed uplink and downlink. We have specific, and also this one only dedicated to you within your house. Okay, for example, you can use this one, talk and walk inside your house only. All right, because this is the coverage, maybe 50 meter or 100 meter. All right, so within your area, within your area. And all these actually the multiplexes that we have discussed previously. All right, so this is the I think we explained this one in the previous class. You can see this one, the second generation. All right, we said that this is the US. All right, this is US, and here GSM, and all these standards, it's Europe. Europe actually, it's UK actually is the leading for this proposal for this one, but they have, I mean, also France, Germany, at that time working together, because the Scandinavian countries like Sweden and Norway, Denmark, they got their own standards, but after that they merged to European. All right, they merged to European. So that's why now Ericsson's, which is Sweden based, they working very hard to, which is one of the leading company in providing 5G. All right, 5G according to Europe standard. All right, according to Europe standard. All right, so here we call it CDMA, code division multiple access, and here we call it WCDMA, wideband code division multiple access. So this one actually is the 3GPP, and this one 3GPP2. All right, here actually is the release. Here actually is the release. All right, so this is the service map. I mean, starting from second generation, we can see voice and SMS only. And at that time, the people really were very happy. And after that, GPRS and eGPRS, in order to provide some internet access and applications. And after that is the WCDMA. You can see it's video sharing, video telephony. And they reach to the 4G, which is, I mean, more faster compared to the previous Gs. All right, so moving actually to 3G high-speed circuit switch data. All right, you remember the circuit switch data in chapter 1 or chapter 2. All right, chapter 2. But here actually it's high-speed circuit switched data, and which is this one, high-speed HSCSD, and also GPRS to provide general packet radio service, to provide data access or internet access, and this one the enhanced data rate for global evolution, which is the edge. All right, enhanced data rate global evolution, if I'm not mistaken. And here is the WCDMA, which is wideband code division multiple access. So this is actually the most important features for the 3G. All right, moving from GSM, which is GSM, if you remember, we said it's 2G, but until the launching time for the 4G, this one they call it GSM. Even the 3G they call it GSM technology. It was really well known at that time. But 3G actually they call it UMTS. UMTS. This one if we are talking about the Europe. All right, if we are talking about the Europe, Universal Mobile Telecommunication Service, something like that, or terrestrial service. All right, so these are the main features, and the main features. This one. Yeah, Universal Mobile Telecommunication Service. All right, so this one is an upgrade from GSM via GPRS or the edge technology, and the standardization work for UMTS is carried out by this one, 3GPP, if we are talking about the Europe system. And the data rate, you can see. All right, see, for example, here we have indoor and outdoor, because in wireless communication actually we have different techniques. For example, for propagation, indoor propagation, we have different techniques compared to outdoor propagation. All right, so it's really different. For example, if you are if you would like to do some measurement about the what you call it, the signals inside AUK campus, so it's really totally different. All right, the results will be outside, because inside AUK they need to calculate the levels, how many levels we have. All right, and also the thickness of wall and the position of people, from which level you are making call to which level you are reaching. So all these actually will affect the strength and the quality of service for the signal. So that's why here, for example, we have indoor and outdoor, rural or urban outdoor. So it's different. All right, and also they provide at that time the virtual home environment. All right, virtual home environment, VHE. All right, which is this one actually to keep the user with the same personalized features, user interface, and all that service, whatever network and whatever terminal, and I mean at any location you are. All right, so this one virtual home environment, like, I mean, you are moving from one system to another system, or you are moving from one service to another service. You are moving from one, let's say, from coaxial, because here, for example, in Dohawk we have coaxial, and which one? It's which other company that provides cellular mobile communication, guys? I know Korak. Is there any?
You mean Asia, Zen?
All right.
Yeah, we have Asia, we have Zen. Yeah, these are the three that
All
provide
right.
cellular.
All right. So let's say this one is a Korak. All right, and this one is for Asia, and this one for Zen. right? So if you are moving from Zen to Asia and to Korak, for sure they have different set of frequencies. As I mentioned here, for example, paired and unpaired. Where is it? Paired and unpaired. Yeah, this one. As I mentioned, this one actually the spectrum is organized and sold. Organized and sold. Then you're gonna purchase this one from the ministry in terms of paired spectrum. So that means there's some set of a frequency, some band of frequency from, let's say, F1 to F10. I don't know, depend. All right, this one for uplink, and another set from, let's say, F11, or this one actually for downlink, and for F11, for example, to F20 for uplink. So this one actually is for Korak. For Zen, they have their own spectrum, which is different. For Asia, they have their own spectrum, which is different. So it's different. So this one actually, they like virtual home environment. That means there is some, agreement, all the companies that my mobile users, they will use your own spectrum for free, keep all the features as is it, and also I will give opportunity to your user to use my frequency for free, and I will keep all the features as is it. Like the roaming, we have home register location, home location register, and visitor location register, all that actually for some management for the mobile communication. Actually, I did search about the spectrum allocation in Kurdistan and spectrum allocation in Iraq, but I didn't find any data. So normally this data should be available online for researcher to do a research and to see the map of spectrum in a particular country. For example, when I was in Malaysia, I was working on one project on spectrum sensing. So from the Multimedia Communication Commission, they have their own website, so all the data are available online. So I just download the spectrum allocation chart and map in that particular area, certain area that I was working on it. And from the map and from the allocation, I start to understand, I start to develop. All right. But here, actually, I didn't find. Maybe, guys, you can help me if you have any source or if you have any information about how to find the chart of the spectrum allocation for all the spectrum.
The frequencies for companies.
Yeah.
Okay, man. I will try to search for it.
Yeah, thank you. If you find, please forward it to me, because I need to really understand how the how the spectrum allocated, and
Okay.
in terms of guard bands, in terms of many features, we can really understand from their own chart. Right. So in terms of UMTS frequency spectrum, all right. So UMTS band, for example, this is unpaired, this is paired. You can see this one for uplink, all right. This one for downlink. So if you use this one, so that means you are in uplink. If you use this one, you are in downlink. All right. So this one unpaired, it's it's a free. Maybe you can utilize for some ad hoc, for some other service, and for some also you can allocate it maybe in future, make it paired frequencies. And all right. So this is how the spectrum for UMTS, for 3G, all right, for third generation techniques. So this one actually is a frequency, all right, frequency 1.9, 1.9, 2, and 1900. All right, so all actually in megahertz, all in megahertz. All right, guys, so I think we will take a break for 10 minutes. 10 minutes only, guys, and we will continue.
Okay, sir.
All right. Okay, guys, we can continue now. All right, so the architecture, UMTS architecture or 3G architecture. All right, for simplicity, 3G architecture. So we have mobile station, all right, and we have base station subsystem, and we have network subsystem, and we have some other network. So it's my connect or it's my not. So in in mobile station, we have this SIM here, SIM card and mobile equipment, and here we have what we call it this one, the SIM card, normal SIM card, we call it the SIM card, but in this one we call it EU SIM, which is the universal subscriber identity mobile. All right, universal subscriber identity mobile, and this one subscriber identity mobile. All right, so this one, the SIM card, we need to insert in our mobile. Am I right? So after that we can enjoy. After that we we can enjoy. And for sure, each mobile has its some international identification number. So this one, if you know this number, then even if you lost your mobile, then you can communicate with your service provider like Korak. Then the service provider, they can block this mobile. Nobody can open it. Even if someone take it, he cannot open your mobile, he cannot go to gallery, he cannot go to anything. So this one is you can register that one. I think international mobile identification subscriber, something like that, which by, if you just call this, if I'm not mistaken, 06 hash, then some numbers will appear. So you can register this number. In case you lost your mobile, then you can just call your service provider, and service provider will take action. All right, they can block this mobile, and nobody can even open your mobile. So I mean, for safety and for privacy as well. So this is very important. You can check. If I'm not mistaken, this is the how you can try actually and check here. Maybe it's star or hash, either star or hash. Maybe you can try this one, and you can check if the number appear. You can register, I think 2 numbers, or you can register maybe on a and save it at a good place. In case of you lost your mobile, or your mobile actually is stolen, then you can at least take some action to save your privacy. And for the base station subsystem, for the base station subsystem, here we have base station or base transceiver station and base station controller. So this one actually, if we are talking about 3G and 2G, for example, here is 2G, all right, and here is 3G. Here is a 3G. So here is this one, we call it universal. Here we call it SIM. Here mobile equipment or mobile. Sometimes here we call it mobile station, MS, and here we call it mobile equipment, MU. All right, or mobile station or mobile, or all right. And here for the base station subsystem, here we have base transceiver station and base station controller. So what's the main difference between base station or base transceiver station? You call it base transceiver station because it actually is transceiver. All right, sometimes you call it BS only, base station. All right, and sometimes you call it base transceiver station. right, base transceiver station, because it's a transceiver. By the way, it's a transceiver. They can receive, they can transmit. All right, so it's BTS. And all right, and this one is the base station controller. Base station controller. So this one actually will take actions. For example, if we have network subsystem. So for example, base station, this is base station. All right, base station controller. Base station controller will take care about many base stations in the area. For example, Dohuk City, we have how many base stations? I don't know, maybe hundreds, maybe 200. So all these 200 will be connected to maybe 2 base station controller, or even 1. All right, base station control. So any times this one would like to go for example, more processing level, like if you'd like to communicate with PSTN or landline, then for sure you will go through this one, base station controller. All right, or for example, if you'd like to go to make a call to another country, then we'll go to base station controller, and after this one we'll forward it to mobile switching center, and from mobile switching center we'll go to the required, for example, the desired country. In terms of 3G, in terms of 3G, we have node B, all right, node B, which is the base station, this one, all right, this one, node B. All right, and this one, the radio network controller, all right, which is equivalent to base station or base station controller. So that means node Bs. If we assume that this one is a node Bs, many node Bs, for example, in Dohuk here we have, let's say 100 or 20 or I don't know, all these will connect to one, for example, radio network controller. All right, radio network controller. In order you have some connections for different level or higher level, then for sure will be through this one. All right, so for the network subsystem, this one base station, all right, so this one base station, this one in 2G, and this one different naming in 3G. For the network system, it's mobile switching center, this one, mobile switching center. For example, as I mentioned, if you'd like to call for different country, this one will forward it to base station, this one will forward it to mobile switching center, which is this one, and after that, this one will take care. All right, this one will take care. So here we have mobile switching center and gateway mobile switching center. All right, so this one actually sometimes it's in one. All right, this one we'll call it mobile switching center, but in details, if you'd like to go for details, then mobile switching center, gateway mobile switching center, and visitor location register. All right, visitor location register. So whenever you move from your area to another area, you will be recorded as a visitor. So all data will be stored in that particular register. All right, visitor location register. All right, and for the for the UMTS, this one, all right, for the UMTS, this one we call it SGSN, which is SGSN, if I'm not mistaken, serving GPRS supporting node. All right, so this one is a serving, this one GPRS, General Packet Radio Service, and this one supporting node. All right, and this one the GGSN, which is gateway, like this one gateway mobile switching center, this one gateway GPRS supporting node. So this one actually is gateway, this one GPRS, and this one supporting node. All right, supporting node. All right, and here you can see this one is a shared equipment or shared element. This one shared element between GSM and between UMTS or 3G. All right, this one authentication center. All right, authentication center that protect database that contains, for example, your secret key, some cryptography algorithms. Security in terms of all the security. What we call it, algorithms, all will be here. Authentication center. And this one, home location register. All right, this one we said visitor location register, and this one we call it home location register. All right, so this one contains all the administrative information about you as a subscriber. All right, about you as a subscriber. In your last known location, for example, you make a call now. All right, you are, for example, in AUK or in anywhere. All right, you make call, so your information will be stored here. That means, for example, at AUK, all the information related to AUK IPs and whatever information will be stored. All right, as the user, this one. So when you make a move, all right, when you make a move and would like to make a call, this one will be moved to visitor location register, and you will be registered and inside this one visitor location register until you try again and again and again. So you will keep moving between home location register and visitor location register. Also, if you are calling from your own service, for example, you have a correct SIM card, so you will be in your this one, all right, home location register. And if you make another call from Zain or Asia, then you will be registered there as a visitor location register. Your information will be registered in the visitor location register. This one also will be, very active in terms of roaming. For example, you would like to visit one city, for example, Dubai, let's say, and you go there. All right, so you will be a visitor. All right, you will be a visitor. All information, all your data will be stored in this register as a visitor location register, and will be double charged. Because why? Because you are using spectrum is not belong to you. All right, so that's why if you use your mobile from overseas, will be double rate, or more than. It's really expensive because you are using spectrum which is not belong to you, and there's no agreement. For example, the communication service provider or wireless service provider in Dubai, they have agreements within that, local agreement. For example, there they have two service wireless provider. They have agreement, all right? And here we have, for example, three, correct, Zain and Asia, so they have agreement. So if I use their spectrum for free, they use my spectrum for free. But if I move there, there's no such agreement, then the charge will be double. And this one, it's EIR, which is the equipment identity register. Equipment identity register. All right, so this one actually is what we call it, decide whether the mobile station maybe it's allowed to go to the network or not. Each mobile has its own identity number. All right, so this one always will be checked through the registration. All right, so what you call it, the equipment identity register. Equipment identity register. So that means the ID for your mobile, the serial numbers and whatever will be stored here. So from this, and here, for example, if we have other network like public switching telephone network, PSTN and PLMN and internet or whatever we have a network, we can, connect through this. All right, so you can see this one from this figure. You can work here, to develop some research related to this one set of frequencies, and you can work here. And also you can work here, for example, in terms of security, because you can see all the information will be stored. All right, so the service provider can really have a clear idea about all your details. So that's why they have authentication. Only a specific person they can access, and only they need a letter from the government. They cannot access, like, simple. All right, but you can work, for example, for security department, you can develop some algorithms for security. Wireless security is a tough area, but interesting and really high demand on the wireless security, especially in the US. All right, the markets in the US really ask for those guys that comes with that. They can develop some algorithms for security purposes. Because when technology develop, all right, that means that the security also need to be high. All right, technology and security will be moving very fast. All right, so this is the general what you call it, the general architecture for the 3G. So we can focus on the lower. All right, this one, and so if you are talking here about GPRS, so that means it's a packet switching. All right, this one actually is packet switching element. All right, this one packet switching, sorry. Yeah, so this one is packet switching element, and this one is packet switching element. This one is a circuit switching element. This one circuit switching element. So you can see 3G actually is a combination between this one and this one. All right, but when they move to 4G will be, packet switching. All right, so I think that's all for this this figure. Yeah, so this one actually is a radio access network. All right, radio access network, and this one base station. All right, base station subsystem that include both this one, second generation and third generation, but here we call it UT run. All right, UT run. All right, so consists of three. Again, this one UMTS is the what we call it, the scientific name, and the commercial name we have 3G. All right, so 3G is much easier. All right, much easier to remember. But when I said UMTS, it's 3G. All right, network architecture consists of three domains. All right, core network provides switching, routing, and transit for user traffic. UMTS, radio access network, UT-RAN, provides the air interface access method and modulation, and this one user equipment here. All right, this one user equipment, this one UT-RAN, and this one the core network. All right, which is switching here, provides switching. This one is packet switching, so all the switching, all the routing, all the authentication, all the the administrative information, the information related to subscribers will be in the core network, this one. All right, core network. And this one, the radio access, provides modulation and all the air interface. It's here in the base station, and the user equipment. All right. Yes, this one, the one that I mentioned, IMSI, International Mobile, I don't know, subscriber or system identification or identifier. I mean, I can't remember the exact name, but this one, if you record it, will be very important. This one, if you record it, will be very important, so you can secure your data, your information, your contacts, your friend, and your. All right, so maybe you can record this number. After you call this number, you just type this one. You will have some numbers will appear. So once that number appear, you can record it, and after that you can, I mean, just in case if you lost your mobile, you can, I mean, take action. All right, you can take action. Will be, I mean, secure. Nobody can harm you. All right. All right, so the UMTS is the third generation, as we mentioned, and follows in the footsteps of GSM and GPRS. All right, so this is the I mean, development of, I mean, from GSM to UMTS. And UMTS, as we mentioned, combine the properties of circuit switched voice network with the properties of packet switched data network. All right, so this is the main features of 3G. And there's not defined from scratch and reuse a lot from, yeah. All right, so there's no, I mean, really, I mean, everything's gonna change, no, because we have, as I mentioned, if you remember, we have 2.5G, some working, so from there they upgrade a little bit and they develop a little bit, they reach to 5G, which is normal. Even in 4G, you can see that we have different release. All right, we have different release, LTE, and after that LTE Advanced, and again in 5G we are in the first phase. All right, and after that we have upcoming phase. It's might called 5.5, or they start 6G immediately. I don't have any idea, depend on the group meeting and the outcomes of their meetings. All right, so here you can see 3G is an evolution rather than revolution. All right, and the UT run is a completely new module. Many components of the GSM network are reused. And this one, third generation partnership project, 3GPP, is responsible for evolving the GSM. All right, so this one actually is related to the 3GPP release. Of the specification include many new features for each the three radio access technologies, some large and some small. Let me show you them. Yeah, I will reshare my screen, guys. All right, so this is the website 3GPP. All right, this one, as I mentioned, it's really important to you guys. Hear about the history, the specification groups, and the calendar, some of what meeting technologies, news and events. All right, and here is the release. You can see them, some white papers, for example, artificial intelligence and machine learning. And now, for example, release 17 All right, so maybe updates. Here is the release. All right, so if you would like to go for any of these release, you can discover, for example, release 99, I think, for the 3G. All right, this is the yeah, UT run. All right, so this one, release 99. All right, release 99. So it's 1999, but after that they make it release 99. You can see here it's release 99. So you can read and you can discover about all the releases until today. All right, so this one starting for 3G, for example. Okay, and after that you can move 4, 5, 6, 7. For example, we are here, release 18. So you can read about release 18. All right, what's going on in release 18? Though this one should be release 18 features should be completed by the end of 2021. So you can discover and you can also do search about this release. You can have, especially in the Federal Communication Commission in the US, also they provide their meeting minutes. So you can, I mean, just discover and you can be aware about the development of wireless technologies. All right. So this one actually it's very important, guys. I really recommend this website to discover. They have many white papers as well, and the news. Some I mean, really nice idea about some development and applications of what we call the wireless technologies. All right, so okay.
Sir, you checked the website I sent you?
Yes, this one, the spectrum. Am I right?
Yeah.
Yeah,
So
this one.
was it what you were looking for, or?
Yeah, but actually, it's not that much. I mean, I feel there is something is not. Um, I mean, it's okay. Can have some. This one. Am I right? Can you see my screen?
Yeah, I can see it.
Yeah, but in certain area, for example, um, in Dohok, what's the spectrum utilization in
Mm-hmm.
yeah, so that one should be provided by the ministry itself, or I mean, how the spectrum utilized within each area. Okay, because for
Okay.
example, this one will be very important if we would like to move, let's say, from 4G to 5G. We need to do some survey study about the spectrum availability. So it's also it will be very important not only to the companies but to researchers as well. If you'd like to do some research related to spectrum utilization in certain area, so it should be, I mean, available. But here, I mean, they give for each company. This one they allocated this one and that one and that one. But how they distribute, how they I mean utilized in a specific area, it's um, yeah, I'm still looking. But this one actually is okay. Even this one I didn't find. I only received from you. So it's, I mean, it's good
Okay.
start. All right, good start. Maybe the companies they have for sure, but I'm not
Well,
sure
yeah,
whether
of
they can
course they
provide.
will have it. Yeah.
Yeah, but I'm not sure whether they can provide it. Maybe the further for their own security. But I mean, in different countries, it's, I mean, available online because researchers they need to take it and do research in order to develop, because there's some
Yeah.
linkage between academic and industry. So they have two ways of cooperations. All right.
Yeah.
All right. So this one, the third generation, for example, I mean, for sure, better spectral uh, efficiency and all right, and data rate for sure. All right. Um, All right, and supporting multimedia application, voice, text, and picture, audio, and video. So I mean, compared to second generation, would be much better. All right, so this one actually is the quality of service. Quality of service. Let me reshare my screen, guys. 1 minute. All right. This one, quality of service, actually UMTS service classes. They divided into four classes. So each classes has its own applications and services. So that means in terms of 3G UMTS, the application and services can be divided into groups. All right, into groups 1, 2, 3, and 4. All right, the application and services can be divided into 4 groups. All right, so it depends on how they wanna consider it. Okay, for example, like packet switching, and for example, if you have the video streaming like this one, or depend on the delay, latency. All right, so they have, I mean, 4 groups. Number 1 is the conversational and streaming. For example, if you have audio and video streaming are important application of UMTS, and here, for example, delay should be 100 millisecond or even less. All right, so this type of application, so an application requires this type of latency or delay, they can go for group 1. For streaming, they can go for group 2. So that means, I mean, for better resource management, they, I mean, divided all the applications and services into groups. All right. So also we can compare in terms of how delay sensitive. All right, how delay sensitive. For example, this one, less than large delay and exceed can be tolerated. All right, and for example, this one and this one is not that much compared for the real time. So I mean, we can compare between these 4 groups in terms of delays and applications. So altogether, this one, they refer to UMTS quality of service classes, QoS classes or service classes. All right, so either UMTS or 3G quality of service, or just UMTS service classes. All right, so this one, for example, for speech service. All right, this one for speech service over, yeah, for speech service, and this one maybe can use for in 3G, as I mentioned, there is a combination. So over this one, okay, either, I mean, for packets, okay, and also it's the link with the circuits. So it's, I mean, either, and this one, streaming for audio and video streaming are important application for UMTS, so they put under this category or under this group. And for interactive, for example, user requests data from a remote application web browser, delay should not exceed a few seconds. All right, this one. And background class or service where the transmission delay are not critical. All right, transmission delay are not critical. So you can see this one can be compared in terms of delay, applications, in terms of delay, set of applications with delay. After that, we can put it in terms, or reorganized in terms of groups. All right, so this one, the release. All right, this is the release that I showed you in the website. So always we can refer to the website and study the release. All right, starting from 99 until now, we have the latest one is 18 according to the website. All right, there is some other websites interesting, like the FCC, which is the Federal Communication Commission. This one actually is in the US, and we have one in Ireland, if I'm not mistaken, Spectrum Shared Company. They provide really amazing data about the spectrum availability, about, I mean, this data, this type of data, the one that I'm looking for, that one actually provide really amazing data. It's a very nice company actually. You can, I mean, they are very friendly. You can communicate with them if you need any, for example, further information about data and spectrum. They can provide some data are free and some data are not free, and they provide also some devices in order to study the spectrum utilization. So it's a good a company, Spectrum Shared Company, if I'm not mistaken. Last time I did communicate with them in Ireland. Yeah, this one during my PhD, I was in need for some data, so I communicate with this one. Yeah, if I'm not mistaken, Spectrum Shared Company. All right, so instead of using the time and the frequency multiplexing method of the GSM, a new method called wideband code division multiplexers. This one actually was, as we explained, it's time slot. I mean, no longer separated from time slot. That means the available frequency will be available for all users. So users can utilize this one by, I mean, same frequency at the same time, but with a unique code. So each user has its own code. And this one we have, in terms of the hardware, we have the code generator. All right. If you remember, we said we have different techniques. This one, the code generator. So that means we'll generate different code for each time user would like to reach the spectrum. And here we have, if you remember, we said we have different communication technique: frequency hopping and direct sequence. Frequency hopping and direct sequence. This one for more secure military service, and not this one for the normal scenarios. All right, so base station are referred to node B. This is the base station node B, and control equipment node B is called radio network controller. So this is the function for node B, the base station, which is air interface. That means transmit and receive, modulation, demodulation. This one we call it air interface, transmit and receive, all the functions related to transmitter and receiver. All right, how to transmit and how to receive. That means amplifiers, filters, all that component we can refer to air interface. And modulation, demodulation is normal. I mean, either you use, for example, digital modulations or types of digital modulations and analog modulations. The main function for this one, it's a radio resource control. This one, the one that I highlighted previously, radio resource control. When we said radio resource, it's include the power, all right, and include the channel, and include the rate, all right, bit rate, and some other resources. So radio resource control, so that means to take care about all these resources. These are the most important resources for wireless communication, and each user, before can make any call, he needs to be allocated with some resources: power, channel, and rate. Power to this user, channel, and also rate. Okay, so channel allocation, which is a part of radio resource. Power control setting, or power control allocation and setting, this one, the power, all right, control setting. So when we allocate this one, we need to control. We need to control the power. The reason why we control power, because we need to minimize interference. We don't want to make really high power, all right, which is generate interference, and we don't want to make really low power. That means the signal cannot reach to the destination. So that means the power must be controlled, all right, must be well controlled. And we have different techniques, and we have different algorithms that provide the researchers to provide, better control algorithms for the wireless communication. And handover control. Handover, that means if you are moving from one cell to another cell, all right, you are changing the frequency, this one cell and this one cell, and you are here, you are driving, all right, moving from this cell toward this cell. All right, so here is different frequency. For example, here is F1, and here is, for example, F2. Here is Korak, here is Zen. So that means you are moving from Korak toward to Zen, or from Zen toward to Korak. At this point, there is some hand off must take and hand over. So that means this base station will take care about you, since you are within the coverage area. So once you are moving away from this base station, moving toward this base station, so that means the base station will understand there is some handover control must be provided to this base station. All right, so this base station will communicate with this one, inform this base station about a newcomer. So this base station will be ready, all right, to prepare all the channels, all the power, and after that, once across this area, then the base station, this one will take care about this mobile, and this one will be released. All the channels provided to this mobile will be released. So this one actually we call it handoff control. So it's very important as well, mechanism in wireless communication. And it's also it's not an easy, especially because when we are driving, for example, across highway, this one the area is 3 kilometers, for example, the radius. So that means we are moving from one cell to another, one cell to another, one cell to another, every maybe 30 seconds, or maybe less than that, depend on your speed. Okay, so you can imagine the process, moving from this one to this one, moving from this one to another one. So it's really not an easy, and need to be really provided with a good algorithm in order to make the handoff smooth. Ciphering, this one actually is related to security, all right, cryptography and security. So each of this one actually is an area of research. This one, radio resource control and management, channel allocation, power control setting, handover control. This one actually it's really huge, all right. Each of it actually it's a big area of research. And the last one actually is related to the segmentation and reassembly. That's related to packet switching, how to segment and reassemble again. All right, guys, so I think I will stop here for today, and we will meet you on next Wednesday. The exam will start at 9 sharp, all right, 9 sharp until 10:15. So 1 hour 15 minutes, or 1 hour 20 minutes, 1 hour 15 minutes will be enough. Yeah, so after that I will give 5 minutes for you guys to convert to PDF and to send either via email or via team as usual, similar to the quiz. All right, guys, so do you have any concern? I will upload, guys, I'm still working on it, the question that are related to last time Ella asked me to provide some questions, so maybe by today or tomorrow I will provide that question, and also I'll provide you with a tutorial related to packet switching, which is that chapter actually is not difficult. All right, guys, any concern, any question related to midterm or related to this class? Yes.
Sir, after Wednesday, we are gonna be done with material, right? Or
no, still we have, some slides here too, because here this chapter is 68 slides. Around 70, 75, something like that. So I'll try to cover the most important topics.
So by next week, we're gonna finish it.
Yeah. The final exam will be 18, if I'm not mistaken, 18 of July.
17th, if I'm not. I think 17th till 19th. But
I mean,
ours, I don't know. Maybe ours is, I don't know.
yeah, I think advanced will be on 18, if I'm not mistaken.
Okay.
Yeah.
So are we going to do anything, any review next week?
I will try. All right, I'll try maybe to, I mean, summarize the most important issues. Maybe, I mean, will help you in final, because this, as I mentioned, this, I mean, this course is not difficult, but it's heavy. All right, so we have
Yeah.
many, yeah, many things to,
Same.
yeah,
We have same problem with analog. I mean, we have 6 chapters, and each chapter is over 50 slides, 60 slides.
yeah, exactly.
Yeah.
All right, guys. So if you don't have any question, then I wish you all the best and see you on next Wednesday.
Okay, sir. See you.
All right, thank you.
Thank
Thank you,
you.
sir.
All right, thank you. Bye bye.